Hello, fourth grade. Yesterday we talked about how do weathered rock pieces move from one place to another, and I set up the stream table that we're going to use as our investigation today. So I want to remind you, a model is a representation of features that might occur on land. They are not the same size, but they are used to study and observe what happens in systems. So this stream table is a model of a piece of land, and the types of soil I used have two different size particles. One was sand and the other was clay. Just a reminder, and remember how this is really powdery. Now, we are going to talk about what happens when water affects land. This represents, see the blue on it? This is a standard water source. So this just means what would happen if it was a regular rain, if it's just regular water that is raining that occurs over time. We're going to place that at the edge of our stream table, and it has a very tiny hole in the bottom. Do you see the tiny hole? That's where we're going to put our water. Now, I also want to let you know, as a scientist, you would have to set up your test so that it is run properly. So I would have had every single one of you in the class make sure that your sand bed is 20 centimeters from the edge. And this is important because right now we're measuring 20 centimeters. We're going to see what happens to the soil and how far out the soil might go when water is added. You'll also notice there is a hole at the end of this bucket, and underneath this tray we have a collecting basin for the water. Now, I'm going to go ahead and we are going to gently pour the water into this container. I have 1 liter of water. It's important that everyone would use the same amount of water. If we were all in the class, every single group that was doing this would also have to use the same amount of water. That is a control. That is not going to be something that changes. So the amount of water we pour into our investigation would be a control because everyone would use 1 liter. And we're going to see what happens as the water goes into our container. Now, it is pouring out slowly. It is pouring out slowly underneath the dot. And we'll just keep filling it and filling it as we go. If I can get this to show you what happens down underneath it. Can you see that? Here. Not sure if you can see what's happening underneath it. Well, I don't think you can see what's happening quite well underneath it. It's pouring right out under the bottom. I'll pour more water in. Now I'm going to just put it on pause because this is just a regular rain. And do we see, when it rains normally, do we see immediate changes in the soil around us? No, we don't. It occurs over time. So I'm going to go ahead and pause this and continue pouring water in until we see if there's any change. Okay, we're starting to get some water coming down from the bottom. Look at what's happening. Okay, so we're starting to see water seeping underneath the bottom of where the soil has saturated. And see what's happening, how it's pooling. Nothing is really happening to the entire mound of soil. Not quite yet. Why do you think the water down here is so milky and white? What could that be? The noise that you hear is the water pouring down out of the container into the bucket down below, so it's not on my carpet. Okay, I want you to keep watching and seeing what happens. If anything happens to the soil at the edge of where the water is coming off. There's water all along this edge. See if I can show it to you from this way. Do you see that? Look what's happening to the soil. Look what's happening to the soil on the edge of, if it was like a bank or if it was on the side of a mountain. Do you see how there is some kind of sand within this water that's flowing? And there is sand, and the ridges, looks like this bank is starting to like have layers. So I don't know if it's falling, if it's sinking. Do you notice what's happening here? And sediment is forming along the water path. All right, so the water is pretty much run out. We've got dripping happening in our bucket, but I want you to notice what's happened with the water that's run off of the dirt. All right, so we have a stream that has come down the center of our container, but the sediment has moved. This is sediment. The sediment has moved and settled, and this is sand. This part is sand, so it moved from here down to this area. So this is partly how rocks are moved from place to place. Water affects things. Now this, if you look clearly at it, there is no sand really in that area. What is that part of the soil? You're right, that's the silt. That's the silt that was within this. So the lighter soil material is carried further than the heavier sand. We're going to talk about erosion. We just witnessed that this is erosion. Erosion is the movement of pieces of weathered rocks by water or wind. We just did this with water. Water moves soil. Wind also does, but we're not going to do that test today. Now, a valley would be the area through which the river flows. So this would be the valley because the river is flowing through here. If this had made a hole within our soil, we would have a canyon. I'm going to stop our video and we're going to take some notes over erosion, deposition, and sediments. All right, in your science notebooks, I need you to write the following vocabulary words. We just learned about erosion, and erosion is the movement of weathered rock by wind or water. We just used our stream table to show evidence of erosion by water. Deposition is the settling process of earth materials that have been moved or carried by wind and rain. And settling just basically means, where do they stop? Where do they stop moving? So we noticed a difference in deposition between the sand and the clay. The sand moved one spot and the clay moved somewhere else. Sediments. For those of you that correctly answered the question about what are the three types of rock, one is igneous, one is sedimentary, and the last is metamorphic. The word sediments, sedimentary rock, comes from sediments, the eroded materials that settle somewhere. That is why Indiana has a lot of sedimentary rock, because the settling of live plants, animals, fish, particles that died settled in the bottom of the river or the ocean or the sea. And then with time, pressure, and more sediments on top of it, formed sedimentary rock, which normally has fossils in it as well. What I want you to see now were the results of what this would happen in real life. So your teachers have a copy of this on they might have downloaded it for you. And there's specific landform words you should know. And so if you were given a photograph you need to be able to label the parts of the landforms. So this right here, where the land has been eroded, this is a canyon, C-A-N-Y-O-N. That's a canyon. This would be your valley, your river valley, where the water runs through, V-A-L-L-E-Y, valley. And last but not least, where all of the sediment ends up is down here. This, and this is a delta. Where the sediments run into water, that is called a delta. For our purposes in our model, that's an alluvial fan. That was made up on land. So when you have sediments that spread out over land, that's called an alluvial fan. For us, we were going to say delta because with landforms, this is the part you're really going to have to know. So for today's homework, this is what I want you to think about. This is your question. This is what I need you to answer. You need to answer, why do you think clay settled farther downstream? We've been talking about complete sentences, making sure you have complete thoughts. So why do you think the clay settled further downstream in our water table? I want you to answer that question and send that to your teacher. Have a great weekend.